Modern Age MCQs, Physics class first year, unit number 2, Vectors and Equilibrium, part number 4. The product I unit vector dot k unit vector cross I unit vector is equal to option A -1, option B 0, option C 1, option D 2. The key is 0. Therefore, the correct option is B. Reason: the unit vectors I, J and K are perpendicular to each other. The product K cross I is equal to J because of clockwise rotation of K towards I, and I dot K cross I is equal to I dot J, which is equal to I dot J is equal to 1 into 1 into cos 90 degree, because the angle between I unit vector and J unit vector is 90 degree, which is equal to 0 because the cos 90 is 0. Hence, the product I unit vector dot K unit vector cross I unit vector is equal to 0. If three vectors of same magnitude form an equilateral triangle by head to tail rule, then their resultant will be option A 3, option B 3 square root, option C 1, option D 0. Key is 0. Therefore, the correct option is D. Reason: the magnitudes of three forces are same. They are the size of an equilateral triangle. Therefore, by head to tail rule, the head of third force coincides with the tail of the first force. There is no arrow joining the tail of the first to the head of a third force vector. Hence, the resultant is 0. If three forces of 10 Newton each are acting along the three sides of an equilateral triangle following the head to tail rule, their addition results option A 0 Newton, B 1 Newton, C 10 Newton, D 30 square root Newton. The key is 0 Newton. Therefore, the correct option is A. Reason: the 10 Newton is the magnitude of each of three forces. The forces are the size of an equilateral triangle. Therefore, by head to tail rule, the head of the last force coincides with the tail of the first force. There is no line joining the tail of first to the head of last force. Hence, the resultant is 0 Newton. Which one of Newton's laws is in accordance with the condition of equilibrium? Option A, first law of motion, B, second law of motion, C, third law of motion, D, law of gravitation. The key is first law of motion. Therefore, the correct option is A. Reason: the Newton's first law of motion states that an object remains at rest, V is equal to 0, A is equal to 0, or in uniform motion, V is equal to constant, A is equal to 0, unless acted upon by an external net force. If the net force acting on a body is 0, the body is in equilibrium because the condition of the translational equilibrium, sum of all the forces is 0, is satisfied. Hence, the first law of motion is in accordance with condition of equilibrium. A point body is in equilibrium under the action of 5 concurrent forces. The equilibrium of the point body will be Option A static, option B is translational, option C rotational, option D complete. The key is complete. The correct option is D. Reason. A body is in equilibrium. The sum of 5 concurrent forces sigma F is equal to 0. The line of action of all the forces passing through a single point. Their moment arms are 0. The torque due to each force is also 0. Thus, the sum of torques sigma tau is equal to 0. Since both the condition sigma f is equal to 0 and sigma tau is equal to 0 are satisfied, the body is in complete equilibrium. Hence, the point body is in complete equilibrium. In which quadrant the two mutually perpendicular components of a vector have positive sign? Option A first, option B second, option D third, option D fourth. The key is first quadrant. Therefore, the option A is correct. Reason. In two dimensions, the rectangular coordinates have four quadrants defined by positive x-axis and positive y-axis, negative x-axis and positive y-axis, negative x-axis and negative y-axis, positive x-axis and negative x-axis. In the first quadrant, a vector is resolved along positive x-axis and positive y-axis. Therefore, both components have positive sign. Hence, both components of a vector are positive in first quadrant. In which quadrant two mutually perpendicular components of a vector have negative sign? Option A first, option B second, option C third, option D fourth. The key is third. Therefore, correct option is C. Reason. In two dimensions, the rectangular coordinates have four quadrants defined by positive x-axis and positive y-axis, negative x-axis and positive y-axis, negative x-axis and negative y-axis, positive x-axis and negative y-axis. In third quadrant, a vector is resolved along negative x-axis and negative y-axis. Therefore, both components have a negative sign. Hence, both components of a vector are negative in quadrant third. If dot product of vectors A and B is 0, then the magnitude of cross product is equal to option A, AB sin theta, B, AB cos theta, C, AB, D, 0. The key is AB. Therefore, correct option is C. Reason. As A dot B is equal to 0 is equal to AB cos theta, or cos theta is equal to 0, which means that theta is equal to 90 degree. Therefore, the magnitude of A cross B is equal to AB sin theta, which is equal to AB sin 90, which is equal to AB. Hence, the magnitude of A cross B is equal to AB. If A cross B is equal to 0 and A vector is not 0, B vector is not 0, then A dot B is equal to option A, AB sin theta, B, AB cos theta, C, AB D, 0. The key is A, B. Therefore, the correct option is C. Reason. As the magnitude of A cross B is equal to 0 is equal to AB sin theta, or sin theta is equal to 0, or theta is equal to 0. Therefore, A dot B is equal to AB cos theta and AB cos 0 is equal to AB cross 1, which is equal to AB. Hence, A dot B is equal to AB. The inclination of a force vector F is determined as option A, phi is equal to tangent inverse Fx over Fy. Option B, phi is equal to tangent inverse fx into fy. Option C, tangent inverse fy divided by fx. Option D, phi is equal to tangent inverse f. The key is phi is equal to tangent inverse fy over fx. Therefore, the correct option is C. Reason, by definition, tangent phi is equal to fy divided by fx, where fx is the x component of vector f and fy is the y component of vector f, or phi is equal to tangent inverse fy over fx. Number 1. If the vector is in the first quadrant, x component is positive, y component is positive, then theta is simply is equal to phi because the angle is measured in anti-clockwise direction. Number 2, if the vector is in the second quadrant, x component is negative, y component is negative, then theta is equal to 180 minus phi because phi is in clockwise direction. Third, if the vector is in the third quadrant, x component is negative, y component is negative, then theta is equal to 180 degree plus phi because phi is anti-clockwise direction. Fourth, if the vector is in the fourth quadrant, x component is positive, y component is negative, then theta is equal to 360 degree minus phi because phi is in clockwise direction. Hence, the inclination of f is determined by C. Phi is equal to tangent inverse fy over fx.